Hello everyone, welcome to our channel. Today we are going to start NCERT exercise 1.1. So our first question is express each number as product of its prime factors. First part is 140. To find the prime factors of 140, proceed. Divide 140 by 2, you will get 70. Then again dividing 70 by 2, you will get 35. On dividing 35 by 5, you will get 7. At last divide 7 by 7, you will get 1. So the factors of 140 are 2 into 2 into 5 into 7. That's it. Our second question is, second part of this question, 156. Proceeding again by using prime factorization method. Dividing 156 by 2, you will get 78. Again dividing by 2, you will get 39. Then by 3, you will get 13. At last dividing by 13, you will get 1. So the prime factors of 156 are 2 into 2 into 3 into 13. It can also be written as 2 to the power 2, 3 into 13. Again here third part, 3825. Now dividing 3825 by 3, you will get 313, 32 6, then 2 22, 37 21, 1 5, 35 15. Then again dividing by 3, you will get 34 12, 32 6, 1 5, 35 15. Now by 5, you will get 58 40, 2 55 25. Again by 5, 51 5 3 5 5 7 35. At last on dividing by 17, you will get 1. So it's done now. So the prime factors of 3825 are 3 into 3 into 5 into 5 into 17. Similarly, you can solve fourth and the fifth part. Prime factorization of 5005 and the prime factors of these, and the prime factorization of 7429 and its prime factors. Our second question is find LCM and HCF and also verify that LCM into HCF is equals to product of the two numbers. First part, 26 and 91. Factors of 26 are 2 into 13. Factors of 91 are 7 into 13. So LCM. LCM is what? LCM is, to find the LCM, you have to write the number, each number with the highest power. Here 2, highest power of 2 is 1. So you can write 2 to the power 1. Highest power of 7, 1. Highest power of 13, 1. So after multiplying all these numbers, you will get 182. This is our LCM. Then HCF. HCF is the common factor of the two given numbers. Here there is only 13 that is common to both these numbers. So HCF is 13. Now second part of this question, product of the two numbers. After multiplying these two numbers, you will get 2366. And LCM and HCF, after multiplying LCM and HCF, you will get 2366. So it's proof that product of the two numbers is equals to LCM into HCF. This is our first part of the second question. Now solving its second part, that is 510 and 92. To find the factors of 510, proceed as follows. 510 On dividing it by 2, you will get 2, 2, 4, 1 and 1, 2, 5, 10, 1, 0, 2, 5, 10. On dividing it by 5, you will get 51. Then on dividing it by 3, you will get 3, 1, 3, 2, 1, 3, 7, 21. Then by 17, you will get 1. Then 92, the factors of 92 are, dividing by 2, you will get 2, 4, 8, 1, 2, 2, 6, 12. Then by 2, you will get 23. Then by 23, you will get 1. So, factors of 510 are 2 into 3 into 5, 2 into 3 into 5 into 17. Factors of 92, 2 into 2 into 23, 2 into 2 into 23. It can also be written as 2 square into 23. So LCM, to write the LCM, you have to written the number with the highest power. There is a 2 is also there, 2 is also there, but the highest power 2 is 2 square. So you have to write 2 square instead of 2. 2 square into other number is 3. There is the 3 to the power 1 and there is 3 to the power 0. That's there is no value of 3. So you have to write 3 power 1 into other number is 5. 5 into 17. 17 into 23. 23. There is not any other number present. So after multiply these number, you will get the answer, and after multiply these number, the whole amount is 23,460. So this is our LCM. To find HCF, you have to find the common number between these two factors. So what is the common number between these two factors? 2 and nothing else. 2, like 2 into 3 into 5 into 17. Other one is 2 into 2 into 23. The only one common number is 2. So HCF is 2. This is the way to find HCF. So again verifying LCM into HCF is equals to, and product of two numbers is equals to, after multiplying these two numbers, we will get 46,920. Okay, and after multiplying these two numbers, you will get 46,920. You can use calculator for this. Okay, so you will get that the LCM into HCF is equals to product of the two numbers, hence proved. Next part 13. Third part is 336 and 54. Firstly, find the factors of 336 and 54 using prime factorization for this. 2, 1, 2, 1, 3, 2, 6, 12, 1, 6, 2, 8, 16. Again by 2 you will get 2, 8, 16, 2, 4, 8. By 2, 2, 4, 8, 2, 2, 4, 2, 2, 4, 2, 1, 2, 3, 7, 21, 7, 1, 7. Now the prime factorization of 54 is 2, 2, 4, 1, 4, 2, 7, 14, 3, 9, 27, 3, 3, 9, 3, 1, 3. So the factors of 336 are 2 into 2 into 2 into 2. It means 2 power 4 into 3 into 7. Factors of 54 are 2 into 3 into 3 into 3, means 3 power 3. So LCM is highest power of each number. 2 power 4, 2 power 1. So we have to write 2 power 4. Then 3 power 1, 3 power 3. We have to write highest power of 3, that is 3. 7 as it is. After multiplying these, we will get 3024, which is our LCM. Now HCF. HCF is the common factor, common number between these two factors. So 2 and 3 are the only common factors. You can see it as a 2 into 2 into 2 into 2, 3 into 7. These factors as 2 into 3 into 3 into 3. 2 and 3. We have only these two as common factors. So we can write it as 2 into 3 is equals to 6. This is our HCF. Now for verifying LCM into HCF is equals to is equals to 18,144, and the product of two numbers is equals to 336 into 54 again is equals to 18,144. So hence proof that LCM into HCF is equals to product of the two numbers. Question number 3. Find LCM and HCF by prime factorization method. First part, factors of 12 are 2 into 2 into 3. Factors of 15, 3 into 5. Factors of 21 are 3 into 7. So LCM is the highest power of each number. Here the highest power of 2 is 2 square. Highest power of 3 is 1. 3 power 1, 3 power 1, 3 power 1. So highest power is 3 power 1. Highest power of 5, 5 power 1. Highest power of 7, 7 power 1. So after multiplying all these numbers, we will get 420. And HCF is the common factor, common number between these three numbers. So 3 is the only common number between these three numbers, that is 3. So this is our solution. Now second part of the third question is to find the HCF and LCM of 17, 23 and 29. Since these three numbers are the prime numbers, so it doesn't have any other factor other than 1 and the number itself. Factor of 17 is 1 into 17. Factors of 23 is equals to 1 into 23, and the factors of 29 is 1 into 29. So the LCM in this case is highest power of 1, 1, product of these three numbers, because there is not any other factor present. So after multiplying these three numbers, you will get 1, 1, 3, 3 and 9. To find the HCF. HCF is the highest common factor, so there is only common number present is 1. So HCF is 1. Now the third part is to find the LCM and HCF of the numbers 8, 9 and 25. Factors of 8, 248, 224, 212. Factors of 9, 339, 313. Factors of 25, 55, 25, 515. So 8 is equals to 2 into 2 into 2, that is 2 power 3. 9 is equals to 3 into 3, that is 3 square. 25 is equals to 5 into 5, that is 5 square. To find the LCM is the product of each number with the highest power. There is a 2 power 3. Other number is 3. Highest power of 3 is 2. Other number is 5. Highest power of 5 is 2. So after multiplying these three, we will get LCM is equals to 1800. You can use calculator also to perform. HCF is the common factor, so there is nothing common between these three numbers, so the common factor is 1. Like after multiplying these by 1, you will again get 2 cube, so you can write it as common factor 1. Question number 4. HCF of these two numbers is equals to 9. We need to find the LCM of these two numbers. Since we know that product of HCF is equals to LCM is equals to the product of the given two numbers. So HCF is equals to 9, LCM as it is equals to A is equals to 306, B is equals to 657. For finding LCM, take 9 to the right hand side. Here 9 is getting multiplied by LCM. So when we take 9 to the right hand side, it gets divided by these two numbers. After solving, we will get 22,338. Question number 5. Check whether 6 power n can end with 0 for any natural number n. For any number to be end with 0, it should be divisible by 10. For example, 100, 150, 250. All these numbers ends with 0 and they all are divisible by 10. So it means the number that ends with 0 are divisible by 2 and 5. That is, they have a factor 2 and 5 in this. Now let us check 6 power n. If 6 power n have a factor 2 into 5 in this, so it should be end with 0, otherwise not. Now 6 is equals to 2 into 3 power n. Here 6 power n includes only 2 as its factor. But we know that for a number to be end with 0, there are factors 2 and 5 in this. Here 6 power n includes only 2 as its factors. So 6 power n doesn't end with 0. That is for any value of n. For n is equals to 1, 2, 3, 4 up to so on. It doesn't end with 0. It always ends with 6. You can write it as in this way. If any number ends with 0, it should be divisible by 10. That is 2 into 5. Factorization of 6 power n is equals to 2 into 3 power n. It's observed that 5 is not in prime factorization of 6 power n. 5 is not there. Hence, for any value of n, 6 power n will not be divisible by 5. Therefore, 6 power n can't end with digit 0 for any natural number n. Question number 6. Why these two numbers are composite numbers? What are the composite numbers? Composite numbers are those numbers which have a factor other than 1 and the number itself. For example, 4 and 6. 4 is equals to 2 into 2. 6 is equals to 2 into 3. 4 has a factor other than 1 and 4, that is 2. 6 has a factor other than 1 and 6, that is 2 into 3. So these two numbers are the composite numbers. And the prime numbers are those numbers which doesn't have a factor other than 1 and the number itself. For example, 2 and 5. 2 is equals to 1 into 2. 5 is equals to 1 into 5. So 2 and 5 are the prime numbers that doesn't have any other factor other than 1 and the number itself. So for these two numbers to be composite, they must have a factor other than 1 and the number itself. So proceeding, we will have 13 common in these two terms. We can write it as 13 as common. 7 into 11 plus 1. 13 as it is. 7 into 11 is equals to 77. 13 as it is. 77 plus 1 is equals to 78. Similarly, here 5 is common between these two terms. We get 5 outside the brackets. After multiplying these numbers, we will get 1008. After adding these two, we will get 1009. So these two are the product of the two factors. It means that this number has other than 1, and the number itself has factors, that is 5 and 1009. Here also this number has factors 6 and 13. So these two are the composite numbers. Now question number 7, that is there is a circular path around a sports field. Sonia takes 18 minutes while Ravi takes 12 minutes to take one round of the field. Suppose they both start at the same time and at the same point in the same direction. After how many minutes will they meet at the starting point? Since Ravi takes 12 minutes to complete one circular path, so it may take 24 minutes to complete two circular paths, 36 minutes to complete three circular paths, and up to so on. In the similar way, Sonia takes 18 minutes to complete one circular path. It may take 36 minutes and 54 minutes to complete 2 and 3 circular paths respectively, and up to so on. So, what is the common time when they meet? When they meet at the starting point is 36. This is the least common multiple of 12 and 18. So, we need to find the LCM in this question. So, proceeding by prime factorization method, we will have factors of 12, 2 square into 3, factors of 18, 2 into 3 square. Least common multiple is the highest powered number, that is 2 square into 3 square is equals to 36. Therefore, Ravi and Sonia will meet together at the starting point after 36 minutes.